You're welcome back to this channel. So in today's class, we want to solve some questions on set theory. So number one, if set A is equal to x such that x is a factor of 72, B is equal to x such that 1/2 of x plus 3 is less than 2x minus 3, and set C is equal to x such that x is less than 20, and A, B, and C are proper subsets of universal set where universal set is equal to integers. So we are going to start from integers. So let's write the elements of universal set. Integers are the positive, negative natural numbers, 0, and positive natural numbers. Natural numbers are the counting numbers, that is the numbers that we count daily. When you start counting, you started with 1, 2, 3, and so on. So those counting numbers, they are the natural numbers. And we have integers consist of 0, and it has negative natural numbers. So everything, that means infinity, negative infinity, then comma, -2, -1, 0, 1, 2, 3, 4, and so on to get to positive infinity. So it goes like that. That means this is an infinite set. Now let's find A. Factors of 72. Factors of 72 are 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36,
72.
and 72. Those are the factors of 72. Now let's simplify for B. Say that B is x such that 1/2 of x plus 3 is less than 2x minus 3. Now let's simplify this inequality. So the first thing that we are going to do is that we have to multiply through by what?
2.
By 2 to eliminate the fraction here. So if you multiply through by 2, multiply everything here by 2, then multiply everything here by 2. So we have what? X plus 6 is less than 4x minus 6. Now let's collect like terms. So we have x minus 4x less than minus 6. Then if this plus 6 comes out, minus 6. So we have what? Minus 3x is less than minus 2. So we are looking for x. What do? We divide both sides by minus 2. If you divide by negative number, or you multiply by negative number in inequality, what will happen?
The inequality sign will be reversed.
Yes, so you have to take note of that. Anytime you divide or you multiply by negative in inequality, the inequality sign will be reversed. So we have x is greater than 4. So the inequality here has reversed. Can you see? So you have to take note. So now we now write B is equal to x is greater than 4. That means we are starting from number that is greater than, immediately greater than 4. So, and that is what? 5, 6, 7, 8, 9, 10, 11, 12, 13, 11, 12, 13, 14, 15, and so on. And so on. Now C is x such that x is less than 20. So all the numbers that are less than 20 from integer will be negative natural numbers, -2, -1, then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13,
14,
14,
15,
15,
16,
16,
17,
17,
18,
18, and 19, because it's less than 20. So we are stopping at 19. Now, let's now find A intersect B intersect C. That is all the elements that are common to the three sets. Now, let's see. There's one here, one is not in B, one is there. So, let's see. What can we find? 6 is here. 6 is here. 6 is also here. 8, 8, 8. 9, 9, 9.
12,
12, 12, 12. 18. 18 will be here.
Yes.
18 is also here. 24. 24 will be here. 24 is not here. So that means we are stopping
At 18.
at 18. So we can now say that A intersects B
Intersect C.
intersect C is equal to 6,
8,
8, 9, 12, 18. So that is how to do that. Number 2, let universal set be equal to 1, 2, 3, 4, 5, 6, 7. P is equal to 1, 2, 3, 4, 5, 6. Q is equal to 1, 3, 5, 7. Find P minus Q in complements. Now, what is P minus Q? P minus Q. P minus Q is the same thing as P intersects Q prime. That is all the elements that we can find in P that we cannot find in Q. So if you want to do that, that means you want to subtract all the elements that is common to both P and Q from P. So you know that we have their intersect is 1, 3, and 5. So you have to subtract 1, 3, and 5 from P. So whatever that remains will be the P minus Q. So that is P minus Q is equal to 2, 4, and 6. Or if you do not understand it that way, you can find your P prime, find Q prime, since it's only Q prime that we need. So let's find Q prime, that is all the elements that are in the universal sets that are not in Q. And those are 2, 4, and 6. Now, this is P. 1, 2, 3, 4, 5, and 6. Let's now find P intersects Q prime. That is the element that they have in common. So you can say that 2 is here, 2 is here, 4 is here, 4 is here, 6 is here, 6 is here. So can you see? So 2, 4, 6. And that is our P minus Q. 2, 4, 6. So to find P minus Q prime, P minus Q prime will be all the elements that are in the universal sets that are not in P minus Q. And those elements are 1, 3, 5, and 7. So that is our P minus Q prime. Question 3. If universal set is equal to KMNPR, X is equal to KMNR, and Y is equal to KNP, find X prime intersects Y prime. That is complement of X intersects complement of Y. So let's find X prime. That is all the elements in the universal set that is not in X. All the elements in universal sets that are not in X. So we have P. That is P. So y prime is equal to all the elements in universal set that are not in y, m, r. So m and r. Now let's find x prime intersects y prime be equal to empty sets. That is empty set since they do not have anything in common, so that is empty set. So that is empty set. Number 4. Let the universal set be set of integers. Universal set is equal to x such that 0 is less than x, less than or equal to 10. So let's write the universal set. X is such that 0 is less than x. That means 0 will not be among all the elements of this universal set. So x is less than or equal to 10. 10 will be included. So we start from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That is the universal set. Find the complement of the set P. If x is element of universal sets, x is not divisible by 4. All the elements, the numbers that are not divisible by 4 from the universal sets, they are 1, 2, 3, 5, 6, 7, 9, and 10. Now, find the complements. P complements, P prime will be all the elements that are in the universal set that are not in P, and they are 4 and 8. Question 5. Given that R is equal to ABC, S is equal to BCD, C is equal to CDE, list the elements of R union S union C. What does union mean? Union means that all the elements that we can find in R, S, and C. So anyone that are repeated, like that are common to them, like C, you have C, C, C. So we write it once. So R union S union C will now be equal to A, B, C, D, E. Number 6. S is equal to 1, 2, 3, 4, 5, 6. T is equal to 2, 4, 5, 7. And R is equal to 1, 4, 5. Find S intersects T, brackets close, union R. So the first thing is that you have to find S intersects T, the one inside the brackets. So S intersects C will be all the elements that are common to both S and T. So let's check. 2 is in S, 2 is in T, 4 is here, 4 is here, 5 is here, 5 is here. So S intersect T will be equal to 2, 4, and 5. Now let's write her now. 1, 4, 5. So S intersect T union her will be all the elements that they have. So we have 1, 2, 4, and 5. Number 7, what is A intersect B in the diagram below? So this is A, this is B, this is C. So A has 1, 5, 2, 3, 4, 6. B has the element of 2, 3, 4, 7, 8, and C has 4, 6, and 7. Now, what is A intersect B? That is where they intersect, where they join, the elements that join them together, the element that they have in common. So you can see that here is the place. They both have A intersects B is equal to 2, 3, and 4. Question 8. If m subscript x is equal to multiples of x and f subscript x is equal to factors of x, find m subscript 3 intersect f subscript 12. Now, anywhere we see x here, we can change it to any figure that we are given. So here, m subscript 3 means that anywhere I see x, I'm going to put x. So that would be multiples of 3. Multiples of 3. Multiples of 3 are 3, 6, 9, 12, 15, 18, 21, and so on. That is all the numbers that 3 can divide without any remainder. They are multiples of 3. Now, F subscript 12 means that anywhere I see X, I'm going to put 12 there. So that will be factors of 12. So factors of 12 are 1, 2, 3, 4, 6, and 12. That is all the numbers that can divide 12 easily without any remainder. So to find M subscript 3 intersect F subscript 12 will be all the elements that are common to both M subscript 3 and F subscript 12. So let's see, 3 is here, 3 is here, 6, 6, 12, 12. So the answer is 3, 6, and 12. Question 9 says, cardinality of P is equal to 4 means that there are 4 elements in set P. Given that cardinality of X union Y is equal to 15, cardinality of X is equal to 20, and cardinality of Y is equal to 40, determine cardinality of X intersect Y. So here we can use Venn diagram to represent it, to explain it. So we have X and we have Y here. So here is the universal set. Now, here X and Y, elements that present in both X and Y, in X or Y or both, will be their union. So we can see that the number of every element here is 50. The number here is 50. Now to find X, cardinality of X, that is everything inside X, will be X only plus X intersects Y. So to find this side, we are given that everything here is 20. So X only will be 50 minus 20, which is equal to 30. Now to find cardinality of Y only, so cardinality of Y intersects X prime, or cardinality of X prime intersects Y will be Y only. So that one will be 50 minus 40, and that is 10. So to find their intersection, so it will be 30 plus 10, which is 40. So 50 minus 40 is equal to 10. So you can see that if we had everything, 30 plus 10, 40 plus 10, 50. So the cardinality of X intersects Y will be equal to 10. Question 10 says, if set P is equal to 3, 5, 6 and set Q is equal to 1, 2, 4, then P intersects Q equals what? Now, we want to find the elements that they have in common. Let's see. 5 is in P, 5 is not in Q, 3 is in P, 3 is not in Q, 5 is in P, 5 is not in Q, 6 is in P, 6 is not in Q, 1 is in Q, 1 is not in P, 2 is in Q, 2 is not in P, 4 is in Q, 4 is not in P. That means they do not have any elements in common. So we can now say that P intersects Q is equal to empty set. Or you draw it like this. So anytime you are considering two non-empty sets and they do not have anything in common, that means you are talking of disjoint sets. So this one gives us disjoint sets. So P intersects Q, P and Q are disjoints. They are disjoint sets. That means they do not have any elements in common. Two elements that do not have any elements in common are said to be disjoint. Now, number 11, if P is equal to 3, 5, 6 and Q is equal to 4, 5, 6, then P intersects Q equals, let's say if they have any elements in common. 3 is in P, 3 is not in Q. 4 is in Q, 4 is not in P. 5 is in P, 5 is also in Q, so they have something in common. 6 is in P, 6 is also in Q. Wow. So they have two elements in common. Then we say that P intersects Q is equal to 5 and 6. Now, number 12. If universal set is equal to 1, 2, 3, 4, and 5. So P is equal to 2, 3, 5. Q is equal to 1, 2, 3. Find the complement of P intersects Q. So the first thing is that you have to find P intersects Q. That is the elements that are common to both P and Q. Let's say one is in Q, one is not in P. So we're not going to take that. 2 is in P, 2 is also in Q, so we are going to take 2. 3 is in P, 3 is also in Q, we are going to take that as well. 5 is in P, 5 is not in Q. So A intersects P intersects Q is equal to 2 and 3. Now P intersects Q, everything prime. That will be all the elements that are in the universal set that are not in P intersects Q. So all the elements that are in universal set that are not in P intersects Q will be 1, 4, and 5. Question 13 says, given that X is equal to EFG and set Y is equal to EFH, set Z is equal to GHK. How many elements are there in X union Y union Z? They say how many elements. They want you to count the elements there. So that's when you are talking of cardinality of sets. That is the number of elements that are present in a given set. Now here, let's write X union Y union Z will be A, F, G, H, and K. You can see that you just have E, E, so you write one E, F, F, you write one F, G is G, you write one G, H, H, write one then K. Now, the cardinality of X union Y union Z, that is the number of elements that is present, or the number that are present here, we want to count number of elements. So let's count. This is number 1, number 2, number 3, number 4, and number 5. So we have 5 elements. So the cardinality of X union Y union Z is equal to 5. 1, 2, 3, 4, 5. So that means it has 5 elements. Number 14, given that the universal set is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, P is equal to 2, 4, and 8, Q is equal to 3, 6, 9, and set R is equal to 1, 5, 7, and 10. So find P prime intersects Q prime. 2. Find R prime intersects P. So solution, let's find P prime first. So the P prime, that is all the elements that are present in the universal set that are not present in P. So they will be 1, then 3, 5, 6, 7, 9, and 10. So let's find Q prime as well. Q prime will be all the elements that are in the universal set that are not present in Q. 1, 2, 4, 5, 7, 8, and 10. And R prime will be all the elements that are in the universal sets that are not in R. That will be 2, 3, 4, 6, 8, and 9. So P prime intersects Q prime, all the elements that P prime and Q prime have in common. So there's 1 in P prime, 1 is in Q prime. 5 is in P prime, 5 is in Q prime. 7 is in P prime, 7 is in Q prime. 10 is in P prime, 10 is in Q prime. So P prime intersects Q prime will be equal to 1, 5, 7, and 10. So R prime intersects P. That is all the elements that we can find in P and we can also find in R prime. So P, 2 is in P, 2 is in R prime, 4 is in P, 4 is in R prime, 8 is in P, 8 is in R prime. So R prime intersect P will be 2, 4, and 8. Number 15. The Venn diagram represents a group of students. If 5/8 of the students wear caps, 1/2 wear neckties, and 1/8 wear neither. What fraction of the students wear both a cap and a necktie? Now, we want to quickly do this. Use Venn diagram. Use the Venn diagram. So here will be the universal set. Now, let's talk of their intersection. So let's use C to represent those that wear caps, and let's use N to represent those that wear neckties. Now here will be those that wear neckties, everything here. So those that wear neckties and cap, let's use X to represent that one. So to find those that wear caps only, it will be 5/8 minus X. 5/8 wear caps. So those that wear cap belong to everything in the circle of C. So to find, and this place are the number of those that wear both cap and neckties. So to find those that wear caps only, we have to subtract those that wear both from those that wear cap. So here will be those that wear cap only. So now to find those that wear neckties only, it will be, say that 1/2 wear neckties. So those that wear neckties only will be 1/2 minus X. Those that wear neither will be outside, inside the box, but outside cap and necktie. So that will be 1/8. So we are dealing with fraction. The whole will be 1. So let's find everything. The number of universal sets will be 5/8 minus X, that is those that wear cap only, plus those that wear both, plus those that wear neckties only, then plus those that wear neither will be equal to 1. So from here, if you do everything, minus X cancel X. So we have 5/8 plus 1/2 minus X plus 1/8 is equal to 1. If you find the LCM, so we have 8. 8 in 8, 1. 1 multiplied by 5, 5. Plus 2 in 8, 4. 4 multiplied by 1, 4. Minus this one over 1. 1 in 8, 8. 8 multiplied by X gives me minus 8X. 8 in 8, 1. 1 multiplied by 1, 1 plus 1 is equal to 1. So from here we have 5 plus 4, 9, plus 1, 10. So that is 10, then minus 8x. So cross multiplying gives 8 multiplied by 1 is equal to 8. So from here, let's make minus 8x the subject is equal to 8 minus 10. So minus 8x is equal to minus 2. So divide both sides by minus 8. X is equal to 1/4. So we can now come here that those that wear both cap and necktie will be 1/4. 1/4. So here will be minus 1/4. Here also will be minus 1/4. So that's how to find that. Question 16 says that list the members of the sets Y such that 1 is less than Y less than or equal to 6. and y is an element of z. And it was also stated that y is a set of integers. So here we can now say that this z will be equal to 1 is less than y. That means 1 will not be included. 1 is less than. So 2, 3, then y is also less than or equal to 6. That means 6 will be included, and we are stopping at 6. 2, 3, 4, 5, and 6. So 1 less than means that 1 will not be included. Less than or equal to 6 means that 6 will be included. So take notes. Number 17, if R is equal to, set R is equal to 2, 4, 6, 7, and S is equal to 1, 2, 4, and 8, then R union S equals, so I told you R union S, union will be all the elements in R or U or both. So you write 1, then 2, 4, 6, 7, and 8. So number 18, in the diagram below, the shaded portion is, now let's say the shaded portion here, it doesn't tamper with P at all. That means that will be P prime, then intersects R, intersects Q. Question 19 says if universal set is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, set X is equal to 1, 2, 4, 6, 7, 8, 9, and set Y is equal to 1, 2, 3, 4, 7, 9, and set Z is equal to 2, 3, 4, 7, and 9. What is X intersects Y intersects Z prime? So here we need Z prime. So let's quickly find Z prime. Will be all the elements that are in the universal set that are not in Z. So 1, 5, 6, 8, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. Now X intersects Y intersects Z prime. So let's write X 1, 2, 4, 6, 7, 8, 9, and Y 1, 2, 3, 4, 7, 9. So X intersects Y intersects Z prime will be all the elements that are common to X, Y, and Z prime. Let's see. 1 is in Z prime, 1 is in X, 1 is in Y. So write 1. 2 is not common. 5 is not common. 6 is not common. 7 is not common. 4 is not common. 3 is not common. 7, no. 8, no. So it is only 1 that is common to them. So let's go to another one. In question 20, it says that in a class of 80 students, every student had to study economics or geography, or both economics and geography. If 65 students studied economics and 50 studied geography, how many students studied both subjects? Now, the universal set, cardinality of universal sets is equal to 80. So let E be for economics, G for geography. So cardinality of E, economics, those that study economics, they are 65. Cardinality of geography, they are 50. Now let's the cardinality of E intersect G be equal to X. So let's represent it on the Venn diagram. Here with universal set, which is equal to the cardinality of the universal set is equal to 80. Now, here is E, here is G. So their intersection X. Now, here will be, this side will be those that studied economics only. So to find that, it will be 65 minus X. Those that study geography only will be this side, and there will be 50 minus X. Now, to find those that studied both, then the cardinality of universal sets will be 65 minus x plus 50 minus x. And the cardinality of universal set is equal to 80. So we have 80 is equal to minus x cancel plus x. So 65 plus 50, that will be 115, then minus x. Now from here, x comes out. If it comes out, it becomes positive. Then 115 plus 8, if it goes in, it becomes negative. So x will be equal to 115 minus 80, that will be 5, and that will be 3. So those that studied both economics and geography, they are 35 people. So we write 35 here, then 35 here, 35 here. Let's check. 65 minus 35, that will be 30. 50 minus 35, that will be 15. So 35 plus 15, that will be 50. 50 plus 30, 80. You can see that we got 80. So that's the answer. Question 21 says, given that the universal set is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Set P is equal to 1, 2, 4, 6, 10. And set Q is equal to 2, 3, 6, and 9. Show that P union Q, close the bracket, prime is equal to P prime intersect Q prime. Now let's find P union Q. P union Q will be equal to 1, 2, 3, 4, 6, 9, and 10. P union Q prime will be all the elements that are in the universal set that are known in P union Q. And that will be 5, 7, 8, and 8. Now, that is P union Q prime. So let's find P prime. P prime will be all the elements that are in the universal set that are not in P. And that will be 3, 5, 7, 8, and 9. And Q prime, all the elements in the universal set that are not in Q, that will be 1, 4, 5, 7, 8, and 10. So P prime intersects Q prime. All the elements that are common to both P prime and Q prime will be 5, 7, and 8. 5, 7, and 8. So hence, P union Q prime is equal to P prime intersects Q prime. Question 22 says the Venn diagram represents three subjects P, Q, and R of the universal sets. Copy the Venn diagram. Shade and indicate the region represented by number 1, P intersects Q prime intersects R. Number 2, P prime intersects Q intersects R prime. So I want to use the Venn diagram in number 1 to represent P intersects Q prime intersects Q prime. P intersects Q prime intersects R. P intersects Q prime intersects R means P and R only. The elements that P and R only have in common. So that will be P and R only will be this place. Because this side is what? P intersects Q prime intersects R, where P and R are together. That doesn't have anything to do with Q. You can see that it doesn't have anything to do with Q. Now let's go to P prime intersects Q intersects R prime. This one means Q only. Elements that are only in Q, Q only. Elements that are only in Q will be this side, where it doesn't have to do with P, it doesn't have anything to do with R. So only Q. P prime intersects Q intersects R prime will be Q only. So this side. So here is what? P prime intersects Q intersects R prime. So this element that we can only find in Q, that we cannot find in P and we cannot find in R, that is P prime intersects Q intersects R prime. It means Q only.